Now? Haha. Okay, thank you very much. Sorry for the short wait. There was a technical issue here on site, but now we're live. Hello to the remote participants. Hello to everybody in the room. Thanks for coming. We have prepared a quick introduction to Datalad, and we'll start right away. I'm Adina. This is Michael. And one thing I need to announce is that this tutorial was planned to take 90 minutes, but Dagmar Keinmüller, who is giving a keynote later today, is sadly not coming. This means that we will take a more relaxed approach. The coffee break will shift 20-30 minutes behind, so we can type a little slower. Alrighty. So welcome, everybody. Happy to be here and joining you in person in Berlin. I want to start with acknowledgements. We're presenting software here, but as everything in science, this is a team sport, so we have lots of collaborators, funders, and contributors to thank. Thank you. And we wanted to be as interactive as possible for this workshop. So what we have brought with us today is an interactive playground. You will have found little slips of paper in front of you at your desks, and they are your username. So while we do a little theoretical intro into what you can expect from the software, just to give you a 1,000-feet overview before we dive into the detailed commands, I would ask you to go to jupiter.edu.datalad.org. I'm going to do this myself as well, just for you to see how it looks like. You will be greeted with this. We're laughing because in person this is a bright green screen. It looks very Halloween-y. I think it's going to look fine for you remotely. Sorry, by the way, for those joining remotely, I don't have a username for you, but you can at least take a look at what we're doing here. And you will have found a username, so maybe your username is Anise. There are spices. You can use the username as it is presented on your slip, and then you set a password, and that password is your choice. Just remember it. Once you have logged in, this is the password that we're going to use. Okay. In case something is going wrong, just raise your hand, and in one of the two short theoretical sessions, either Michael or I will come around and see if anything needs to be fixed. Alrighty, I wanted to start by giving you a quick overview of potential use cases for which you may want to use Datalad, or how you can see Datalad used in the wild. So one thing that Datalad is it is a behind-the-scenes infrastructure component for lots of services that you may already be using. For example, OpenNeuro, or if you've been to the CBrain tutorial, also CBrain. So if you go to OpenNeuro, which is this very rich repository of freely and openly available datasets, you will be used to just finding a dataset that fits your needs right, and then you can see it has a Datalad or Git URL, and you can use this URL just as it is shown here in the screen recording to Datalad clone, a similar thing like Git clone, a dataset that I think in this specific case is 1.2 terabytes in size, and then you have a single file access, or access to the files on a single file level. You will experience that yourself in the tutorial, but data consumption from portals like this, or employing it as a behind-the-scenes component, that is one strong point of Datalad. A different thing, more on the individual scientist side, is that you can publish or consume datasets via the services you use anyway. For example, GitHub or GitLab, the Open Science Framework, the European Open Science Cloud, or similar services. Here's a screen recording that points straight to GitHub, and it's the Study Forest dataset. So you're seeing in this screen recording again a clone command that takes the URL, just as you may do with a code repository. Again, it is cloning this really fast. By now, this is nothing new. And this Git repository, while it lives on GitHub, looking like just a regular Git repository, small in size, actually contains some fMRI data amounting to, well, not 1.2 terabytes, but a couple of gigabytes. And you can see that I can browse the available files here and then get specific files that I need for my next research project. That's nice. And I can also publish that. You can use it to create and share reproducible and open science. So that means you can not only share your data, but also your software, the code, and the provenance. Here's a paper that I wrote a couple of years ago. If you go to that GitHub repository, you will find links to the preprint and everything. But then when you clone this repository, it's not actually only the sources of the paper. It is fully reproducible. It contains actionable links to the software, in the form of a software container, to the data. And if you want to, you can go to that repository now and have the entire paper, all stats, all figures recomputed on demand on your computer, and check if it reproduces bit identically, if all of the results in the paper come out exactly as they are on the publisher's website. This is also a nice example. I'm very fond of that. This is Lennart Wittkuhn, who did a beautiful thing, our bookdown project with Datalad, and I think a couple 100 gigabytes of data behind that. It's really beautiful, much more accessible than, you know, a LaTeX paper. So you can also do it in like something more user-friendly, whatever framework you prefer to publish your science. We use it in our institute, the Institute of Neuroscience and Medicine, as a central data management and archival system. So if you're a data manager, this might be something for you. So a researcher in our institute can go to our internal GitLab instance, find a so-called datasets repo, which is a superset or super dataset of all of the datasets we have access to. And on our own compute structure, people are able to clone this dataset, and in this dataset they have first of all an overview of all of the original preprocessed and archived datasets that researchers in our institute are provisioned with or provided, and then if they have the right access permissions for a given dataset, if they filled out the DUA, for example, they again can get actionable access to these datasets for their computation on our cluster. That's nice. For consortia, like collaborative research projects, we provide a data catalog, which makes data discoverable, fair, without necessarily providing the data freely available. You can use it to annotate the data with some metadata as well, but simply making it findable across sites already is a great way to collaborate on data, including, if you want to, links to these binder instances where you can actually run analysis on these data sets. And then we also use it to do really large-scale reproducible processing. If you're interested in that, then I would point you to this publication where we provide also a detailed tutorial. Alrighty, by the way, if you want to follow along with these slides, which is useful when we start programming, I would point you to the URL that this is hosted from. If you go to slides.edu.datalad.org, on the front page you will find a link to this workshop, and by clicking the spacebar, you will be able to follow along with the slides as I am presenting them. Okay, and before I hand over to Michael, I would quickly like to get to know you, just to help us gauge in which way we can assist later when we go into coding. So I would ask you to either go to that URL or scan the QR code with your phone. I will leave this up for just a minute or so. The remote participants are welcome to answer here as well, but it is a less actionable piece of information for us. Does anybody need more time? Okay, then I will start. What I would be interested in is learning whether you are using a version control tool already in your day-to-day workflows. Fantastic. Thank you very much, and this is great, so we don't need to start with the Wagner. And what I also would like to know is which operating system you use to work. So whether that is a computer that you regularly work on or a cluster, whatever you conduct your science, or other job in, what operating system does it have? Beautiful. This is useful. This is very, very useful. For the person here on Windows, feel free to grab me or Michael later full time. So if there's any difference in the computer environment that we've brought compared to what you're used to, then we're happy to point out the differences and show you how it works. Okay, thank you very much. I will hand over to Michael. And if there's anyone who needs assistance with the user account, you can just wave at me and I will come to your computer.
Okay, so Adina gave you a long list of use cases that Datalad can be applied to. What I will be doing is to break down Datalad's functionality in very few principal components to offer a slightly different approach to what Datalad does. At the core of Datalad and everything that it does is a data structure that we call the Datalad dataset. And it is essentially a version-controlled data structure that can take anything that is part of the digital aspects of research. So you can put in any files with any format of any size, pretty much. And these are version controlled, and the way you lay out the files and which particular format you use, Datalad doesn't put any constraints on those. So usually people do whatever is best practice in their communities, right? So you can combine the best practices of community standards with best practices of data management in a way that it's essentially done as how you would use code management for development process, software development process. The way these slides are structured is at the bottom, you can always see a few examples of how that actually looks like in Datalad, right? So Datalad at its core is a command line utility, and here you can see at the bottom left, this is the command that you would run to turn a regular folder on a computer file system into a Datalad dataset that has then these capabilities. So exhaustive tracking of everything that you can put into a file is Datalad's core business. And when we have the ability to put all kinds of files of any size and number in such a data structure, what this enables us is to also capture how we can turn inputs that are in files into outputs that are in new files. And Datalad provides very simple functionality through the run command, where you can simply say, I have these inputs and I will be generating these outputs, and you prefix that command to the command that you would actually run, like the execution of an analysis tool or a script that you wrote for a very specific purpose, and you just type Datalad run plus something else in front of that, and Datalad will record a machine-readable message that captures exactly how these output files came to be. So in 6 months or even 5 years, you can go back and you have that taken care of. So in addition to the exhaustive tracking of everything digital, we also capture the provenance information that connects these two entities. And if we can put all that information into a Datalad dataset, what we have essentially created is a portable data structure that can capture the entire digital research process. And Datalad has, much like Git has, a push command where you can say, okay, I want you to share whatever I have here locally with a particular data service, right? And that data service can be something like GitHub that you've seen in the examples, or more specialized repositories that Adina also showed in the use cases, right? And that's quite liberating, right? If you can transport a local environment that you need for conducting your research to another place. And if you can push it away, you can also clone it back onto another system. And this allows for that data structure to be used as basically a vehicle to transport all the necessary information in an actionable way to a consumer, right? And that consumer could be you on a different machine, right? Maybe even in parallel. It could be you at a different institution in a couple of months or years, or it could be a collaborator, or it could be a reviewer of a publication that you handed in that just wants to make sure that what you describe in the paper is also what's done in the analysis. It allows for really deep inspection and also feedback, which is even more relevant for collaboration. And there's another feature called Datalad Rerun that can capitalize on that, where you have a component in Datalad that can act on these machine actionable provenance records that you can record with run and allow you to programmatically recompute parts of the data set, which can be used for many different applications. So, and if you put all that together, what Datalad enables, and that's really the core purpose for which it has been built, is it allows you to compose and maintain modules that capture individual research outputs, and it captures them in a way that you can verify and re-verify trust in the integrity of these components. And because you can do that, you're facilitating incremental research, right? So if you're thinking there has been a PhD student in the lab that you just joined that has produced something, the PhD student already graduated, moved to a different institution, so there's really no very direct way of communicating. But if they have put their outputs in a structure like this that has actually captured 3 years or even more of work on these, you have access to that in written form, and you can also programmatically verify whether the promise that is implied by this research output is also can be trusted and through verification. So these modules you can connect to each other. You can have an output of somebody else be an input for one of your projects. And this has really no end. So the outputs of you can be an input into other people's research efforts with the same implications of verifiable trust. Okay, and taken together, Datalad is a tool that you can apply to every little layer of the onion that is the collaborative research world that we're in, right? So lots of people working on data quality control, lots of people working on analyses, lots of people working on visualization, and you can collaborate with anyone using these tools, and you're not constrained to a particular local environment. You can just share that information like it is done in the world of collaborative software development, for example, right? Just extend it to data. Okay. That was my very brief introduction of the really basic ideas that are behind Datalad, and now we can pretty much start with the hands-on. And you can use, maybe we do it like this. Okay. So what I'll be doing is I will just so this is a Jupyter Hub deployment. We're all working on the same machine somewhere in the cloud. I have logged in, you will have logged in in a similar way with your account, and I'll just open a terminal. And maybe make it a bit bigger. Oh, just for now like this. So the first thing we need to do is, so this is all new account, right? So none of us, even if we're using it all the time, we have any configuration over there. So we'll do git config -- global, and then we set a username for each. I will use mine. And then we do the same thing for an email. If you have been using Git, this is not a surprise to you. At some point, possibly years ago, you did that for yourself. And Datalad is a tool that sits on top of this German keyboard, that sits on top of Git. So we are relying on pretty much the exact same mechanisms. Okay. And the last thing I will do in that Git configuration, I will set a particular flag. I'll be trying that by copying this thing. I'm not copying, I'll just type it. What this does is it sets a particular configuration flag in Datalad that Datalad has. So first of all, Datalad is using Git's configuration mechanism, so Git config that the Git users have surely experienced before. And what this particular configuration flag does is it tells Datalad to use an extension. So you can extend the Datalad system with independently developed extension packages. And the next extension is a particular one that's also developed by the Datalad team, which packages features that have not yet trickled down into the Datalad mainline, but maybe improve particular functionality, provide additional commands. So that's the complete setup that you have. What you haven't seen is how you install Datalad, because that's already available in this environment. But you can go to the Datalad documentation or the handbook, which we'll point out later, that has setup instructions for every environment. Okay, so that puts us in a position to actually create a data set. And we can do this here in this folder. It's all empty. And if we want to create a Datalad data set, you've already seen that in the slides. We use the Datalad create command, and at the minimum, you need to tell it where to create the data set, and that will just be the name of an analysis. That will just be the name of a directory where it's created. Simple as that. And we will do one thing in addition. We'll give it a so-called configuration procedure that it's supposed to run. So configuration procedures you can supply yourself. Datalad brings a couple that are essentially just patterns that you apply to the created data set. So if I run this, you will see that there's some extra stuff that is running. I'll just run that now. Is there a way to disable that sidebar for now? I tried, but folder? This? Ah.
It's also nice to see that the directory was actually created, right? Yeah. And so the file browser, if you're used to...
Okay, so we'll leave it there. Maybe we turn it off once in a while. So you've seen that the folder was created, right? So the maybe for now, we'll just switch here, just go through. So here you can see Datalad telling you that some extra commands have been started. This is the configuration procedure. But ultimately, what we got was this My Analysis folder, and that My Analysis folder is also go here. It doesn't contain much, but if we look at the hidden files, you can see there's some stuff in it. Basically, just Git things. And now I invite you to just take a look around in your account. If you see something that is strange that you cannot explain to yourself, feel free to say it, and then we can talk about it. Otherwise, I will slowly continue. So we have for those who know Git, They know if there's a Git repository involved in the top level directory. There's always another directory called .git, where Git stores its state information and version control. You probably also have seen a Git attributes file. That's a way to inform Git how it should treat individual subdirectories or files in the Git repository in a particular way. The one thing, if you have used Git but not Datalad, that you haven't seen yet is the .datalad directory. And that contains just a file. And in that file, Datalad has recorded a globally unique identifier for that data set. And that's useful if you want to talk about what's in that data set in the context of metadata, right? So if you have attended Luba's workshop in the first round, you'll have heard about metadata and possibly also the importance of identifiers, etc. And this is where Datalad makes the connection to such system. Okay, so in general, fairly normal thing. And now we can use this as a version control system, right? So that's the first thing we're going to do. And I will again make an attempt to copy this command. This time I will use completely new ways. Control is probably no. No, I cannot. So I'm not equipped. So I'll type it. I'll be a bit shorter than what's there. Have you ever had the situation where you use a keyboard that you're not used to and things become a lot slower than they should? Okay, read me. Okay, so this is a Unix way of saying I created a file with a misspelled name. So I need to fix that. You know, just for aesthetic reasons. Okay, read me. I think this works, right? Okay, so if you know Git, you know Git has Git status, right, which informs you about the state of a repository. Datalad also has status, so you can run Datalad status, and it will give you similar information like Git. It does it in a slightly different way. We don't have really the time to talk about all these things. I will just mention for the Git power users, Datalad tries to ignore Git's staging area, try to skip that step and just work with whatever is committed and what is not. So here you can see it finds the README file as an untracked file. That's Git's and Datalad's way of saying this is there, but we don't deal with it. It's not yet version controlled. And then in Datalad, if you want to put something on the version control, in Git you would need now this add commit combo. In Datalad you just have save. I could run Datalad save just like that, and it would turn everything that's untracked into something that's tracked automatically. You don't need to think, right? So in case you rather have the snapshot, you just run Datalad save and think about everything later. But of course, it's good practice to give this a commit message, right? So create a short README is the commit message that we're going to use. You can give it directly to the command, and then we run this, and then this also looks slightly different than what Git would be doing, but here you can already see, now that we're seeing it the second time, this is a general pattern in Datalad, right? It gives you a summary report of all the operations that it executed, so you can see here that it added the README file to the repository, then it saved the data set, and now we're done. So if we're running Datalad status again, there's nothing to save. The working tree is clean, right? So everything has been captured on the version control. And now I invite you to also follow this along. We'll just modify the README that we created to demonstrate the rest essentially of the version control very simple version control process. This data set contains a toy analysis. I'm getting closer. And then this is the way to modify an existing file, just append that statement to the file. And again, the Git users will know Git diff shows the difference between files. And now you might say, well, this is the Datalad tutorial. Why is he showing me Git commands? That's one of the ways Datalad is built. Datalad sits on top of a software stack, kind of you can think of it as an orchestration tool, right? So a Datalad dataset in this form is a Git repository. And we're just using Datalad to manipulate that Git repository, but it stays a Git repository. And that has various advantages. For example, you can take that Datalad dataset everywhere where Git is a known thing, right? So GitHub, a public service company that many people use, or GitLab and all the various other ways of hosting Git repositories, they are all compatible with Datalad datasets because a Datalad dataset is nothing but a Git repository, right? And that is also important for your considerations whether you want to trust Datalad with your research, right? So there might be that you're moving to a place where Datalad cannot be used for whatever reason, right? And now we've created many things with Datalad. Is that a problem? Well, it's at most a convenience problem, right? Because it's still a Git repository, and every place that can work with Git, which is a lot of places, right? You will still be able to benefit from what you did with Datalad. Okay, so here's the diff. If we want to capture that change, right? We can say again Datalad save, and we can again give it a message, add information on the data set. I'll cut it short. And you can see it has again figured out on its own that there was a README that was changed, added it to the repository, saved the data set. And now again, you could use git log, which is Git's very, very basic tool to inspect the history of a Git repository. You might be using other tools, also with graphical environments. There are many for the terminal, for example. There's TIG. Git itself provides Git-K, and there are various other graphical user interfaces or integrations with coding system like the popular VS Code editor, for example, knows how to navigate these things. And so here you can see the full history of the dataset that we created some time ago. And we can essentially retrace how it happened just from looking. It's not a close inspection, right? We're just listing the commit messages. And you can see Datalad captured when it itself created the dataset. It also captured when immediately after creation this configuration pattern was applied, right? And then these other two commits we did in the demo, just two modifications of a file, and you could now do a deeper inspection. But at its very, very basic, right? This is how you change or switch from a folder with stuff to a version controlled folder if you're using Datalad, right? You run Datalad create exactly once, and then after every meaningful step, after every meaningful change, you run Datalad save, and you give it a short or long note of what the meaning of that change is, right? And this is, if you just continue that for a couple of years, you will have something that nicely has recorded what was done, right? In a very manual fashion, but that's basically it. Nothing else is really, really needed. Okay, do you want to take over, or?
Given that everybody already knows and even works with Git, this version control recap can be really short. But just to give a quick summary on like the simple commands that we have seen, what that means on the conceptual level, that's version control. So I really love this little comic here of XKCD. Lungfish says, it turns out I've been editing both copy of gene v3 newest 2 and copy of gene v3 final 2. So now I can't delete either one. The little guy says, you have got to stop doing this. Lungfish replies, it's fine, I'll just buy more storage. And the caption is, why lungfish have such enormous genomes? And that, in my opinion, sums up the issue that version control solves very neatly. When you use version control, you have a nice history rather than a mess of files with idiosyncratic version extensions. You will know all of the benefits of version control, and this is precisely why Git was built and why it is rightfully so popular. But what Git doesn't do well is handling large files. If you have ever used a Git repository and you commit, yeah, that's true, I can make it larger. If you've ever used a Git repository and you accidentally added something into that Git repository that's not a text file, but maybe a brain image, then this will have caused you issues. To very much simplify the process that underlies this, consider this graphic here. You can see here version 1, version 2, version 3, so a progression of 3 files, A, B, and C, in a Git repository. You can see that whenever a file is changed, it gets a little increment number. Whenever it doesn't change, the previous file descriptor stays the same. So in the first revision, there's ABC. In the second revision, files A and C get a revision, and so forth. Now, this works really well with text files. Git is excellent at managing differences between small text files, in a very space-efficient manner. The issue is when you have a brain image, let's say it's a nifty, it's 5 gigabytes large, and then in the next commit that you make, you do a tiny modification of that file. You simply capitalize a field in the header, a byte of a change worth. Git has no concept to efficiently store the difference between the first version of the nifty and the second version of the nifty. So what this means is you add another 5 gigabytes into your Git repository, and this is blowing up. So if you have revised your nifty 3 times, like in this graphic, then you have 20 gigabytes in the directory in this version control directory. And the issue is, so Git can still handle this. It's an incredibly powerful tool. I have tons of respect for how they do that. But if you are to clone this, if you are to push this, then all of these operations need to be performed with 20 gigabytes. Like, it's not only the issue that GitHub won't accept that, or GitLab, or wherever you would push it, but even cloning this dataset needs to download 20 gigabytes when you clone it from a server. And sometimes you see that with published science, people just put everything in Git, and then you end up Git cloning for 5 hours. And if you do that too much, like, it's not only an inconvenience, but it breaks the Git repositories eventually. Git can only do so much, and after a while, you've wrecked it. There's nothing that can be meaningfully performant in there anymore. And this is why Datalad uses not only Git, but also Git Annex, which is the software that solves tracking large file contents without checking them into Git. So in Datalad datasets, you can add all of these nifty images, you can save them, but they do not add to this cost of downloads immediately upon Git clone. Instead, and we don't have too much time in this tutorial, so I will just glance over this, any large file, and not only large files, but any file that you would not want to have in the Git version control system is placed into what we call an annex in the dataset, a special place that you and Git Annex can use to even on per file level decide where files should go, whether they should stay only local, whether you should use institutional storage for them, and that all while tracking their content identity. So you can have a precise content identification of your nifty image that tells you if anything changed, if you did any modifications to that file, without having the cost of tracking all of that in Git, while still being completely transparent to Git in the sense of, hey, something has changed. Procedurally, this makes version control extremely easy. You have created a dataset, and once you did this, you add files, whichever, and you say Datalad save, and that's it. And if you are a Git power user, then you know that meaningful units of change and helpful commit messages make for a nice history that also others and your future self can use to find out what has been done. Those are really the basics of version control in Datalad datasets. So let's now take a little bit of a look into data transport, because that, I think, is also one thing where Datalad is extremely useful. 1 second, I have to find my slides again. Here we go. So we're going to execute a Datalad clone call. I'm going to clear the terminal. Control L is what that does. Notice that I'm still in the My Analysis directory, and now I'm executing Datalad clone. And what Datalad clone needs is a file path or a URL to a dataset. So I will try to copy this as well. Okay, so in principle, this call Datalad clone of a URL is complete. We need nothing more than that. I'm going to add additional optional things. One thing I'm going to add, at the end of the command, I'm going to say, you know, I want to be very transparent and easily understandable in how my analysis is structured. So I don't want to use the directory name bits data for the published dataset that I'm going to be obtaining. I want to call that input because it's going to be a data analysis. And I want to make it clear this is input. And the other thing I'm going to do is I'm going to add a flag that's -d, it's short for --dataset, and I'm pointing that to the current directory. I will explain in a couple of slides what this is achieving. But for now, let's stick to data transport. So if I'm executing this, you can see that it is cloning it. And let's hope that the Datalad hub is, completely fine. So you can see lots of things have happened. And if I open the file browser again, there is a directory inside. If you like the graphical interface, then you can also use this browser here to, take a look at what is in there. You can see that it's a tiny but bit-structured little data set containing some data. So I will change directories into this data set as well with a cd change directories command, and I can look around also from the terminal. This provides me now with the same view. You can use whatever you're more comfortable with. And one thing I want to draw your attention to is, I know this input data set is really, really small. Even though there is a nifty in there, it's not the world. Still, it was pretty fast to clone, and if I ask for the size of this directory with the disk usage command, du-sh, it's printing the disk usage in a human-readable way, it's really too little of occupied space to contain a nifty image. So what is happening here? Let's take a look at how the tools inside work. I'm going to run a command that's called git-annex-info, and this is giving me information on this dataset and its contents as the underlying version control tool git-annex is seeing it. You can see this is quite lengthy, but there are a couple of interesting pieces. So for one, this first section here, that tells us, or this gives us a hint, that this is a decentralized system. You don't need to understand this, but what this identifies, or this is a list of alternative places where this dataset or its contents or some parts of it are available from. All of these are known to Git Annex. So we have obtained this data set that exists in a decentral network on all kinds of places. You can see that, you know, Adina at Mannen, this is my personal computer, but you can also see that it's Jupyter Lemongrass on this IP address, which is the current computer that I'm on. This is also why it's marked here. So, toy analysis, but decentral space of availability. What you can also see is that there is an identification of annexed files in working tree 2. This means there are 2 files that Git Annex is tracking in this data set. And you can see the size of the annexed files in the working tree, which is close to 50 megabytes. So while the clone of this data set is really small at the current stage, it's actually much larger if we were to obtain the file content. And what we're going to do now is to query the version control systems where it might obtain this content from. So I'm going to, first of all, extend this info call to a specific file, just for you to see what may be known about a file. You can see if I tab complete here into the subjects to func directory, you can see there are JSON files and TSV files. They have a normal markup, and you can see this nifty file that has a weird markup. And this is an indication of that file being tracked with Git Annex. So if I tab complete into this path and run info, then what I can see is, for one, its file path, human readable. I can see its size, and I can also see a key. This key is a mix between an MD5 hash that identifies its content, then its file size, its extension, and the backend, MD5 with extension. Not so relevant, but for everyday use, but still interesting to see, because underneath the hood, everything in this system is identified based on identifiers. So while there is a human-readable file name that makes it easy for you to see the file, to interact with it, the system underneath identifies everything based on its contents. And then there's present, and this value is set to false. The file content of this file is not present. If I were to open this thing up, even if Jupyter Hub could open nifty images, I would get a very weird error message. And what I can also do is I can ask where this file is. So I change this call to ask Git Annex where is. And then it provides me, based on its knowledge of this decentral system, all of the locations it knows this file could in principle be obtained from. Not all of these locations would work. My private computer, no way this AWS machine would be able to access it, but it may be still useful for me to know, hey, it's on this USB stick in your cupboard, right? So that I can plug it in. So let's now see that in action of what that gets us. If I'm just lazy and type datalad get me the subdirectory, that's enough, then I'm downloading the file content as I need it. I see a question in the audience.
Where is the information actually stored? So this information which of these decentralized repositories exist? Because I couldn't find it in the files.
Yeah, excellent question. I'm repeating it for the remote participants. One audience member asked where the information on availability in this decentral network, for example, about a file, is actually stored, because it's not in the file. That's absolutely correct. It is on a specific branch. If you run git branch in this directory, you will see there is a master branch, which is standard, like your main branch in Git, and then there's a Git Annex branch. And this Git Annex branch is where all of the information on availability is stored. It is exclusively managed by Git Annex, so all of that is happening underneath the hood without us needing to do anything. It's recorded automatically, synced automatically, or synced if we want to. Yeah.
So if this is pushed to GitHub, for example, this information will be retained.
Exactly, exactly. And if you don't want to push, then there are means to keep that private. You can mark an individual repository as, you know, this content, like this, we don't want this node to show up in the decentral network. Okay, thanks for the question. So you've seen that I've obtained file content, but what is probably equally useful is that I'm able to drop this file content as well if I don't need it anymore. So by running Datalad drop, which is the antagonist of Datalad get, I can free up space. And that's incredibly useful once the datasets get a little bit larger than that. And importantly, this drop is only acting, you can see it thinking a little bit, it's performing security checks in the back. It's only acting on files that can safely be reobtained. It's a configurable thing, but drop would refuse to act on a file that I only have locally. It will only drop file content without complaining that I can retrieve. I can force it to drop file content, but yeah. And that's how data transport works. And you've seen that, or I've promised you to go into the details of what this -d dataset flag that I provided in the beginning with the clone command. So you're still, like, just to recap, we're in this input dataset. And if I run git log, then you can see it has quite extensive history. I'm currently in a pager, you will be too. You can navigate with the arrows keys up and down. And if you ever want to get out of there, you have to press Q. But you can see all of the history of this dataset, which reaches as far back as 2023. Importantly, nothing in here resembles the history of the dataset that we ourselves created, right? This is a standalone history. It is a reusable module that I can now use to make sense of what has happened in this dataset. If this is data I'm obtaining for a data analysis from a person I don't know, this history is my path to potentially understanding what I have in front of me. This is very, very useful. What I want you to remember is this latest commit up here, 345C. Just the commit hash, because what I'm now going to do is I'm going to go one directory up again into my analysis dataset, and then I'm going to show you the git log of that dataset again. One thing you can see is that all of the original history is still in place, add information about the dataset, and then there's one additional commit that was performed when we performed the clone command. And I can do a git show of this commit. Let's see if I can copy paste here. I'm just going to type the first few characters, not so much. And that has very minimal information. You can see it's nothing about the history of that standalone dataset underneath it, but it has its path, its origin, its ID, you can see the Datalad ID here, and then importantly it has what is called a sub-project commit, the 345C9 commit hash. And this is everything that is recorded here, which is where does the dataset come from, where is it now, and what version have I recorded it in. And that is enough information to provide an actionable and versioned link to, in this case, a data dependency that I can use for my analysis. And Datalad is proud of making this nested structure of Git repositories and Git repositories and Git repositories, we call them sub-dataset hierarchies, really smooth and mono-repo-like. So if you have ever used a Git submodule, that's a painful experience. If you work with hierarchies of Datalad datasets, you can easily forget that you have sub-datasets in front of you. And I can now query the dataset of which sub-datasets are available, and here it's a single one, but there's really, really no limit to the amount of datasets that you can have. We have datasets with thousands of sub-datasets underneath them. Yes?
But if you push them to gin, then they will complain.
There's a question that said if I push the dataset to gin, it will complain. What do you mean?
When you have many sub-datasets, we have tried this, and yeah, they sent us an email that you shouldn't do this.
Oh, okay. So somebody in the audience was a power user of Datalad, pushing apparently tons of sub-datasets to GIN, which is a service run by the University of Munich, I believe. So congratulations, well done.
If we have time at the end, we can show you something that doesn't play.
Okay, yeah, to just recap this is the mechanism in which, basically reuse is very easy. We call it nesting, and then you have a dataset and you link sub-datasets into it. So we have these super dataset, sub-dataset relationships. And then you can do something like this here in the scientific kind of example where you have modular pieces in your project that each warrant being standalone things because either they can be reused or like the pre-processed dataset, or because they need to stay private, locked away, like the raw dataset, or because they're just a final input, a final output, like the paper. But although all of these things, like each of these little dataset icons here, they can be individually cloned, reused, consumed, whatever, they are still linked all the way to each other. And this allows something that is indicated here with the 2 papers and the 2 analyses. They both can depend on the very same input preprocessed dataset without any additional work. The preprocessed dataset is a modular thing. It can be reused as many times because it is so modular. And it also allows for, let's say, a reviewer of a paper to go as far down the processing pipeline or the processing history as, for example, data sharing allows. So a reviewer or collaborator can, from the paper, go to your analysis, maybe make some changes, make the next project, do a recomputation, find out what has been done in the preprocessed dataset, maybe not go all the way to the raw data because that is private, right, so you keep it locked away. But all of these workflows are very smooth and easy and also very disk usage friendly because these actionable links, they're a couple of bytes. It's a version hash, and it's 5 lines in a text file. That's all that is. Yeah, this is what I've already talked about. Okay, so unless there are more questions here, which there very well could be, I've glossed over lots of things in the data transport section. So any questions? We can also go into a little bit more detail later. Yes?
You mentioned that Datalad one could basically pipe any comment, right? So basically that echo message could also be
yes.
done via Datalad.
Yes. So the question from the audience was, we mentioned that Datalad run can pipe any comment. So we could have done the echo command in a Datalad run. And that's exactly right. And this is also what we're going to do now, because now I want to continue to the next piece I wanted to showcase, and that is reproducibility. And for that, we're going to add more things into this little toy analysis data set. I'm going to clear my screen again with Control-L. So the first thing I'm going to do in preparation for that is I'm simply going to download a script from the web. So it's a wget command. I have misspelled it. It just runs, it just takes a getBrainMask.py Python script and saves it underneath its name into a new directory code. This has worked. You can see there's a new directory code. Yes?
Wouldn't we actually run this when they can run better? To track where the code is coming from?
Excellent, excellent comment. So a member of the audience has asked, shouldn't I run this in Datalad run? He is absolutely right. There would be even better commands, but I wasn't prepared for such an attentive audience. So we have, sorry, this is in the wrong. We have a new directory code next to our input. This has a script. I can also check what the version control systems think about this. They say, hey, there's a new directory. It isn't tracked yet, and I can Datalad save that now. Obviously, it would be nicer with Datalad run, but I haven't introduced that command yet. So I'm adding a nylon-based script for brain masking. Okay, so all saved, all clean, awesome. So let's start basic with recording provenance. So oftentimes we have things that create a difference in the files and outcomes that we produce. One thing is, for example, code formatting. And I could take a code formatter like Black in the Python world and let it run across my script. And then this formatter will find lots of things that I may have not programmed so nicely. I can take a look what those were. So you can see, oh, it found lots of things. I used the wrong quotes. There are some spaces I should have rather used instead of that in this. So it found a couple of things. And in a non-provenance tracked world, I would maybe save that. But if I would return to something later and maybe not find a descriptive commit message, I could simply forget why something was done. And it doesn't need to be a code formatter. It could be the execution of a script with a parameter that I did not record anywhere. And that information is gone then. So it is useful to keep track of these transformations to be able to later explain what has happened. So I'm going to do that. So I'm going to discard this change. Thanks to Git, I can simply say, yeah, there is a difference here, but I really don't want it. Throw it away. You can see it's all gone now. And I'm going to bring up the very same command, Black get brain mask, Black code get brain mask, and I'm going to wrap it inside of Datalad run. And in principle, this is enough. Just Datalad run and then a command that follows it. I'm going to be nice to my future self and add a commit message. So I'm going to say reformat code with Black, and then I'm going to execute this. And what happens is the same processing as before. Code file is much nicer now, but the provenance was recorded. And let's take a look at what this provenance actually looks like. If I do git show, I will close this again so that we have more space. You can see for one, the diff that I've already shown you. This is just what has been changed in the script. But what you can also see is my commit message here. That's just to have a concise summary right available in the Git log. And then there's something that is squeezed in between these do not change lines markups. And that looks a little bit funky, but you can find, for example, the command that we ran in order to do the reformatting. And this record, we call it a run record, is the way that Datalad internally records provenance. While it is somewhat human readable, it's mostly meant for machines because this record contains not only provenance of what has been done, but it contains actionable provenance of what has been done. So I can, for example, take this identifier up here. I'm going to copy that. Let's see if that works. And then plug it into the Datalad rerun command and have that re-executed. And now there's one thing that I wanted to show you, which is fantastic for reproducibility, although it has nothing to do with code formatting. So if you will notice, like, I have repeated formatting on this file, but Black has already formatted it, right? There's nothing it would be able to find. So let's take a look at the history on how that looked like, or how that looks like. Because what I will find in the history is the one run commit I have executed, but nothing more. The rerun currently does not show up in the revision history. And the reason for this is that nothing changed. Had I run a process that would not yield an identical result, then I would get a new commit, transparent on top of my current revision history. But given that this is all in this very same state as before, the version control tool has nothing to save. And this is a very useful way to, in data analysis contexts, find out whether your analysis reproduces or which pieces of your analysis do not reproduce, may be subject to easy or difficult fluctuations. Okay, that was an incredibly easy toy analysis, and it all benefited and relied on the fact that I installed black on this computer before you accessed it. This is never going to happen with brain analysis because you will, in many cases, have a week-long project in front of you trying to install the software dependencies before you can attempt to get a script to run. And one way to make software execution easier and portable across systems and users are software containers. They are not without flaws, but there are many cases in which they are very helpful. So software containers, quick show of hands, who has never heard of a software container? Perfect, cool. So Datalad can work with software containers, and for that there is an extension that equips Datalad with commands to work with them. I'm going to clear my terminal again, Control L, and I'm going to copy-paste this command, and that's Datalad containers add. Datalad containers add is a command that obtains a software container from a path or a URL, also from your local system if you want, and adds it as a version-controlled entity into your dataset. Depending on the software solution behind the container, can be a single file, can be multiple files, depends on whether it's a Docker container or a Singularity container, for example. And the structure of this command is Datalad containers add. Then I'm giving that container a name. I'm calling it nylon because it pretty much only contains nylon. And then I'm providing a URL. In this case, it's a URL to Singularity Hub where I've deposited a container for this purpose. And if I run this command, it will take a little while. It is downloading the container, 300 megabytes in total, and register it as a tracked file inside of my dataset. I can also run Datalad containers list in order to see what is available. In this case, it's only a single one, the nylon container. And now I can extend my Datalad run call into something that's properly complex, like a proper complex analysis. So I'm going to type this here just to explain to you the different steps because it contains lots of options I haven't previously discussed. So I will say Datalad containers run. The first element, I've already used it in run, is the commit message. So I'm going to say I'm going to compute a brain mask. And the command that I will be running is Python code get brain mask. There are so many things that I can mistype now. Let's see if it works the first time I'm running this. Just to recap, we have the script that has the brain masks computation, and we have the subdata set with input that contains the data that we need, and lots of secret sauce inside of the script that I could have shown you but didn't. But the script takes this input directory and computes a brain mask from it. This would already kind of try to work. It would not have a container specification. If I were to run this outside of the container, it will fail. I don't have nylon installed. But I can specify a container in which I want to run this. Oh, if I wouldn't mistype it. With the -n flag. And now I'm going to do something that is going to be helpful immediately. I'm going to declare inputs. The inputs that I need, I have the secret knowledge because I've written the script, or I've asked the person who wrote the script, or I've taken a look at it. So one thing that I need is obviously the Nifty file. And I don't want to go through the trouble of obtaining that myself. You know, I've dropped it, it's not there at the moment, but I still need it in order to have this script execute successfully. So let me just auto-complete this. And then, with this flag, I have instructed the run command not only to obtain this file for me in order to let the computation succeed, but it is also something that's recorded in the digital provenance so that when I repeat the processing or that somebody else repeats the processing, that this can be handled automatically. It's not only a convenience for myself right now, but it's also a crucial piece of actionable provenance that ensures that this relevant input is present if somebody wants to repeat the processing. And then in the same vein, I'm going to declare what is going to come out of this. And I'm lazy. I will just say, you know what, I think it's going to create a figures directory. I want everything in there to be an output, so I don't need to know in advance. I could also just say a wildcard everything. And I know that this is going to produce a second output, and that's called subject2, which is the subject available in the bits directory. So now we can see how many typos I've made. So what you can see here now is the first step is obtaining the nifty image in the subdataset. You can see how this flawlessly works or operates across dataset boundaries. It is absolutely irrelevant that I am in the super dataset and the data comes from the subdataset. And then it was really fast, very, very short computation. So after the retrieval, get OK, it is already running the analysis. You can see this is happening with Singularity. And then it computed all of the records. I can also take a look at them here in my file browser. You can see here is the figures directory. And because it's Jupyter, I can also just open it up and take a look. And yay, it's a real file. Hooray. And I can take a look at the individual file that I've created and its individual history to find out, hey, how did you come to be? Like, I'm receiving this data set and I want to know what is the history of the file. I can just ask it. And then the file will tell me, oh, you know what? Michael Hanke created me just a couple of seconds ago. And he did it using these commands. And then I can say, oh, great, let me rerun this and see if the process is bit reproducible. Let's see. And one thing that you can see is that there is one OK save. So let's take a look at what that is. Now you see there are two run commands because parts of the computation would not produce a bit identical file. I can use tick to maybe take a look what exactly it is. And it's the brain mask. It's the nifty file that has some changes. And if I would want to find out what they are, I could now take the previous version of the nifty image and compare it to the current version with specialized tools. And that's nice. It's a very, very useful tool set at my hands here that I can use for reproducible science. Okay. And with that, we are already at the end of the content that we've prepared here for you as a quick rundown of all of the things. What we brought with us here on the last slide are pointers to pieces of information that you may find useful if this has interested you and you want to know more or you want to get started. We have a website that points to everything that's relevant. What may be especially useful is the Datalad handbook, which is a user-oriented tutorial. So if you want to find out what you can use the tool for and get recipes, then you can go there. We have a Matrix channel that runs a weekly office hour. So if you want to have a problem, a data management problem that you want to talk about, know how to do something with Datalad, you can just join our call. There's lots of open data if you are in search for data. I think, let me check, I think it's 800 terabytes that we have. No, 650 terabytes, sorry. But they're right out there. But given that we have time, I would suggest that we make it an extended question session. So if you have any specific questions or maybe you want to see something else, then take the opportunity of me and Michael being here, and let's talk about what is interesting to you. Also, the people remote. I think you can probably ask questions somewhere in the chat. Okay, awesome.
One question. So I think
Yeah, first of all, maybe you want to repeat the question for the remote people. Sorry.
Sure. So actually, when my question is that when you basically have actually you know a large data set, you know, maybe for example like the hundreds of subjects, and then when you have already actually developed a pipeline, right? You know, so actually like you know all of the steps in the processing, you know, the kind of the input output, as well as the kind of actually these messages that you want to add basically for each step. So then, well, is there actually a way, you know, to basically integrate this kind of a data provenance system, you know, into a SnakeMake, you know, that we are generally using for the processing? Thank you.
Yeah, there's, but the exact way you want to do this would require a bit of a closer look of what really the problem space is. So in the simplest way, you can do it exactly like that, because if you're using SnakeMake, you're basically saying SnakeMake, right? And you point it to a snake file, and it does its thing. If you write Datalad run in front of it, you're done, right? But it also can be done in a different way. So there is a Datalad extension that actually provides a wrapper around SnakeMake's file retrieval mechanism. So you could also have Datalad work inside SnakeMake, and then you could run, you could start a SnakeMake workflow without the data being accessible to SnakeMake. And then Datalad would take care of getting that. The reason why I said it requires a closer look, it depends on what your desired outcome is, right? So Adina mentioned in the beginning a paper that says fairly big something something. That is looking to some degree at that problem, because you might want to create a situation where you produce a reproducible outcome and you want to enable other people in the, let's say, distant future to rerun that, right? And then you need to be very careful what it is that your workflow is executing, right? And maybe you would want to use a Datalad of in 10 years at the time where you run that, and not the one that you had to put into the container in order for SnakeMake to be able to exercise it, right? So it's, you know, it works in both ways, but which one is the clever one is hard to tell.
I have a hopefully not too technical question. So regarding containers run, so if I understand correctly, by default it stores the container that I add as a large binary in Git annex inside the repository.
Yes.
But let's say I have a container that I like to, or several containers that I reuse across different projects. So I have like my whatever container, and then I use it in different projects. This means that, and this container has a significant memory footprint. Well, of course, this one is small, but if I have one which is like 50 gigabyte or so, I don't want to replicate it for my 50 analysis pipelines. Does it make sense to store the container images themselves in a subdata set?
Absolutely. Absolutely. This is also what we do in the case of this big workflow. Maybe I'm just using this here to illustrate that, where the software environment, in this case we called it a pipeline, because it was a really extensive pipeline development that we had to do. I think it took a month or two until the pipeline was eventually like properly written down and packaged and containerized. So that's a standalone software subdata set module, because that can then get reused over and over again. Exactly. Depending on the system that you're running on, though, like I've also heard of collaborators who use this approach on an HPC system where the administrators then were not so happy with this usage pattern. But in general, I would totally recommend that. Yeah, but
so not so happy with replicating the.
They were unhappy that because this was running across thousands of compute jobs, and every time it would retrieve the software container again. So they were angry there. But then every kind of computational system has its perks, and the system at least provides the flexibility to adjust the workflow that you create to whatever your local needs are.
Okay, thank you.
But maybe a quick addition. I think the what you suggested turns out to be probably the most popular, most frequently reused Datalad dataset that ever existed and still exists. There's a US project called Repronym, and they maintain a collection of neuroscience-related containers. It's called the Repronym Containers dataset. It sits on GitHub. And you can just put it in there and say, I want to use FY prep of version such and such, and there's nothing you can do, and you need to do, right? It's all pre-configured, and you just type in the Datalad containers run command, and you use those things, and it pulls the container from wherever it is.
So the approach that Datalad takes by default, which we just did, this is just the default behavior and can be changed if necessary. So if you want to use like these containers instead of the ones that you the default locations, that's possible.
So it's basically just an application of what we said earlier, right? That you're essentially maintaining reusable modules, right? And the Repronym people, they decided they want to maintain a collection of files that happen to be container images, right? And put it up for everybody to use.
Okay, cool.
Thank you very much. I have two questions about Datalad Run. One is that, so suppose that I'm just developing a code that I'm not sure if it works correctly. I mean, it may not. I'm assuming that if it leads to an error, there is not going to be a comment. But if there is not an error, but I want to inspect the output, should I run it first myself, and then if I'm happy with the output, then remove everything, rerun? Or should it be part of the provenance, like the evolution of that code?
So this is an excellent question in many ways. So one thing I should mention is that the Datalad run will only result in save if the exit code of whatever you executed is 0. If it's a non-zero exit code, then you will be left with the remains of your process, whatever files, intermediate outputs and so forth were created, so you can inspect that if you want, but you will not have the addition to the dataset unless you want to like salvage something. So it is perfectly fine to say, you know, I'm just scripting, I want to try it out, and let me Datalad run it because it's part of my process. And then what you will end up with is Datalad run saying, hey, I encountered an error, and this is all untracked or modified or whatever outcome you created. You would have the exact same thing if you were not to use Datalad run. And then afterwards you can either say, okay, this still has things that, you know, I need, I can selectively commit this, or I can clean it away, I can restore things. And then the question of, should I record the provenance of my work in progress or not? I don't think there's a one solution fits all answer to that. I would definitely caution against trying to make everything right and only then recording, because if you look back, like after a 2-week vacation, you will find value also in intermediate steps. At least this is true for me. The analysis that we often run in the neurosciences, they are so complex. They never, rarely ever, like maybe other people are more capable than I am, but they are rarely ever right the first time, and you discover the errors like only a couple of weeks ahead. And having this trace, even if it's only for you, to have this like little memory hint of, right, this is how I used to do it, and now this is the difference between. That is useful. Or in order to be able to later compare, right, we fixed this. We fixed an error in our script, and it is affecting the results in this manner. So maybe our hypothesis doesn't hold anymore now that we have fixed something. All of this can be useful. But again, it's also a question of, you know, what kind of disk space can you afford? If your analysis produces a terabyte of outcome, then it may not be feasible to store the outputs every time. Yeah.
And maybe on the last point, there are tools in this package where you can say things like anything that's only referenced in history, right? So a previous commit that has been replaced by something else and it is not tagged, drop the content that is no longer needed. So you theoretically, you could capture every single step, right? But in general, when you're doing it, you have an idea what is meaningful, and then you can do also just that.
And one thing that is nice, outside of the Datalad run command for this kind of experimenting, when you're not sure what is going to work, because we're in a Git repository, you can make use of all the powers of branching. So if I go back to my PhD project, then I have probably a dozen branches in this dataset where I am testing different preprocessing pipelines. And that is also a nice way. It's outside of Datalad run. I can use Datalad run on the different branches, but this is an additional nice thing to abuse for science. And then later you can say, oh, this is the thing I wanted. I'm going to merge it. And these approaches all turned out to be useless. I drop the data so that I don't have to carry it around, but I'm keeping the provenance, the Git provenance, for example. I'm just going to tag it away. And it's out of your sight, everything is neat and orderly, but in the revision history, there still is this possibility for you to investigate.
There are no other questions. I have another question about Datalad 1. About input and output.
Yeah.
Would it be automatically detected? I mean, unless not running in parallel, probably like in a parallel execution paradigm, it wouldn't work probably. Mm-hmm. But output could be figured out based on like what is added.
Yes.
Input also maybe there are mechanisms, or like is it against your policy? Or?
No, not at all. With output, yes, there is essentially auto-detection, because run and containers run and rerun, they all operate with the same procedure. You execute a process, whatever is happening in between you starting that process and ending it in the dataset is going to be saved. So if you don't specify outputs, everything that gets created would nevertheless be saved. The useful piece or the application for outputs, there are two, I would say, which is why we recommend specifying it, is for one, when you want to rerun things, because everything in datasets is when it is annexed under special protection, because you don't want to do accidental overrides. Like the version control system protects it. So in this case, you need to define what an output is in case recomputation changes it, so that it is transparent to the version control system. You are allowed to change this output. I am okay with that file being changed and modified and versioned again. The other piece is by default, because of the simple way it's essentially built, like run something and then inspect the changes and save them, Datalad run and containers run by default will only act in datasets that have a clean state, where you don't have modifications and you don't have untracked files. But this is not always the way that you work. Sometimes you have stuff that's simply just lying there and you don't want to save it, you don't want to move it away. In these cases, you can give the explicit flag, and that will only save things that are explicitly declared as output and leave everything else the way it was. For these cases, it's fine. The auto-detection of inputs is less easy. In principle, you can have really broad declarations. You can say, just give me everything. This is extremely costly, depending on how much data is actually linked there. I mean, an alternative, you won't... I don't think there's a middle ground between you being either like broad or providing like exact paths. We definitely can't like look into your scripts and figure out what gets used. And the tools that you use, like Python scripts that want to access a file, they rarely encounter, like there is no standardized error message, right? If you open a file where the content isn't there. It's on Linux systems, it's a broken symlink. Then they will crash with one error message, while Python pathlib library will say something entirely different, and Windows will lose its shit anyway. So yeah, with input, not as easy as with output.
Thank you. I would have another question. So regarding batch systems.
Regarding?
Batch systems,
yeah.
Slurm,
yes.
for example. So I know that there are own limitations regarding running Datalad inside or outside parallel processing, but I mean actually, so I often find myself like having a submission command of a job, and I would like to record that. So I don't want to put like Datalad run, srun inside the script and want to record that, because I basically want to record what I actually did. And what I did is submit script this, and later when I rerun, I want to basically repeat that. But there's this time delay because it immediately returns.
Yeah.
Is there a solution, an extension, or some best practice for that?
Do you want to take it?
I can do it. There are also many ways to do this. We have used, that's best written up in this paper, a way that essentially orchestrates the jobs that are then individually executing Datalad run, and so the batch system is used to schedule the jobs, and then each job is basically clone and a parameterized Datalad run call. And when you do it like that, what you get is a provenance record that can be re-executed by someone who does not have access to that original batch system, right? So if you're thinking about reviewers, etc., or you're thinking about what happens after the decommission of the HPC system that you used, right? It would still work, right? You would not have the problem of scalability solved for whoever wants to do that, but for spot-wise checking whether things are in order, that would still work. And exactly. So earlier this year, people from the Helmholtz Center Dresden-Rossendorf, they developed a Datalad Slurm extension, which does it the other way, right? So I think it does exactly what you're asking for, right? So you are leaving the orchestration completely to Slurm, and you are no longer treating the entire batch execution as one running job, but you are saying, do me all those, and then they come back individually. It has nothing to do with Datalad. And then you have some sort of a collect at the end that just takes all the results and makes the respective commits. Right?
I think you manually run a Datalad slurm finish command of sorts.
Yeah.
And that can be like a month after everything is finished, like whenever you next log in.
And this is much more compatible with the way HPC systems want to be used. And this also creates less portable, less provenance records with less longevity. But, world isn't perfect.
But it would basically help. I mean, I see that it wouldn't help, for example, a reviewer as much, but it would help me more.
Yes,
exactly.
So if I, probably a combination, so probably at some point doing it properly and in detail would be good, but like when you are iterating jobs, this is exactly...
It was very fascinating to us working with them, because the HPC perspective is something that is a little bit alien to the scientists using the HPC system. So I was always a little bit timid before the HPC people, because I'm like, I'm sorry, I'm abusing your systems, but also like they don't want me to like work in the way that I need it. But then the HPC people came around and said, you know what? Let me actually show you how we want it to be done. And we said, okay, this is interesting. Thank you.
Cool, thank you.
Yeah, if there are no immediate questions, I think I want to use we still have a couple of minutes. I want to show you a recent development in this ecosystem that Datalad is a part of, which would solve Amir's problem of people writing him back complaining. So I'll just give you that mic. Thanks. So we run a conference called Distribits that actually ran last week. And if the stuff that I'm talking about is interesting to you, you might want to go there and take a look at the talks from this year and last year. This year's talks are not yet there, but those from last year. And in that community, which is people interested in distributed data and its management and what you can do with it, people have gotten together and created something that's called Fogeo Annexajo. Who knows Fogeo? Who knows GitHub? Imagine you could run GitHub yourself. That's Fogeo. And Fogeo Annexajo is Fogeo with the ability to do all that. Like everything we talked about, Datalad, Git annex, full compatibility, but on a server, but also done in a way that you could run it on, every device, 50 euro, whatever, as much storage it can take. And I want to show you the, let's actually use Hub. I hope that's on. So here's a deployment that we use for demos, and if we, I'm not even going to log in. You can see it looks pretty much like, well, we'll use a bigger one. It's less. This machine at the moment is a bit slow because apparently the world needs data, so AI crawlers are torturing. I'm not sure we can use this. Oh, I'm logged in. Is that okay? So you can see it's very slow, but we still have time. You can see it looks a little, similar to GitHub, and I'm looking for one specific test. Here's test resources, and so we open one individual project here. It's called Nifty1 test datasets. And then you'll see the similarity because it just gives you, did I click? Yes. Yeah, that machine is at the moment visited by 10,000 other machines per hour. So it's doing its best. It's not yet done. Here we go, right? So you have this typical presentation. There's the content of a repository. There are the commits. So everything that we showed in the terminal, you can see in the UI, right? And this system also can take data, right? So when you have a, gigabyte limit at GitHub, if you don't pay them substantial amounts of money, this system has no limits. You can take whatever you gave it a hard drive for, right? So if you need to store a couple terabytes, a couple 100 terabytes, that's not an issue. And what's even cooler is this system understands Git annex, right? So if I don't know if you see the symbol here, whenever it says 01 in the beginning, that is a file that Datalad has put via Git annex into this repository. So if I click on, which one is the one I want to click on? Maybe this one. So this is a demo Nifty file. It's not that big. It should open eventually. So just as an explanation, right? So this is not a huge institutional deployment. This is just one small virtual machine for €4 a month, right? So it's pretty much anybody can do that. So and when you open that file, you can see it shows you something about that file, right? That is something you wouldn't expect for example, for GitHub to happen, right? They tend to be ignorant of neuroimaging for whatever reason, right? But this is a system you can easily customize. So what it shows you here, that's the header information in that Nifty file, right? So this is just, I told the machine, output this whenever somebody visits that, because looking at the binary is not really informative, right? You can take that customization even further. You can, for example, click on this Nye View button, which is a hard test of bandwidth. We'll see. So it has opened another application. I just clicked on that button, and if we're lucky, we're going to see your brain. Any second now. So this is now combining the struggles of this network with the struggles of that machine, right? Well, we have to wait for the brain, right? It's a brain workshop. Ah, here we go, right? So that's it, right? And this thing is live. And now what you've just seen is a GitHub that does targeted neuroimaging visualization. And so the entire system is completely customizable. If you want to, Adina showed at the beginning the work of Leonard Wittkuhn, who has basically produced a book that is interpreting a data set that captures the outputs of his research process. If you end up with a particular, standard of laying out some information, for example, like the bits structure, right? You can put code in this system to present that information that it contains nicely, right? Rather than you scrolling through tons of files, it would immediately give you information about how many subjects, what are the types of information that are available in this data set, right? So it's all right there for you to use. And there are a number of deployments of this system already, and there's a collaboration in Jülich together with the atmospheric scientists to develop this further. So we have multiple instances like this in Jülich running, one for brain, one for climate data, and so on. So this is a really exciting development because it enables that everything we've looked at today, which is having Datalad, Git, and Git Annex as a local client software, and having to, gain the expertise to use those, is not really necessary to work with these outputs, right? Because this thing provides a web-accessible API. So if you are, proficient in JavaScript and you just want to hack something together, you can have an instance like this that hosts many, many terabytes with information from many, many subjects, and this is all accessible by HTTP request, right? So this is extremely powerful and is very well integrated in this ecosystem that is surrounding everything that we talked about in this workshop today. So I personally think that's really cool. That's why I wanted to bring it up now that we had more time.
Yeah, and I guess I can add to the more time thing, because I just learned that we have a full hour of a coffee break. So let's grab all of the coffee, talk a little bit more about Datalad. Maybe they still have dessert.
Yeah. But maybe we should do that then where the coffee is.
Yeah. Thanks for everybody's attention. You know how we look like. You can get in touch or talk to us. We'll be here for a little while longer. And thank you for having us.
Oh. One more thing. I just want to point out, Adina glanced over it a little. This is the Datalad handbook. It has everything that you need to know. And you can search through it. It's free. You can have a printed copy, whatever is the best way to learn it. This is also extensible. If you find that something isn't really there, or you have come up with a cool solution, you can contribute to this, right? So this is always the go-to place if anybody wants to learn about Datalad and everything else. Okay, thanks.